In the world of software development, there's a secret weapon that ensures the quality and reliability of your applications. It's called unit testing. What is included in unit testing? Unit testing is a crucial practice in software development, and to understand it fully, it's essential to know what's included in a unit test. A unit test is designed to evaluate individual units or components of your code in isolation. Here's what you'll find in a typical unit test: test case, test data, test framework, assertion libraries, setup and teardown, mock object, and test coverage. 1. Test case. Every unit test starts with a test case, which is a specific scenario or condition that you want to test. This could be a particular function, method, or part of your code. 2. Test data. To assess how the code behaves under different conditions, you'll include test data. This includes input values, parameters, or data sets that you'll use to test the unit. 3. Test framework. Unit tests are executed within a test framework, a software environment that supports the test's execution. It provides essential functionalities for running the test, capturing results, and managing the testing process. 4. Assertion libraries. In unit testing, assertion libraries are used to specify what should happen during the test. These assertions define the expected outcomes, allowing you to check if the actual results match your expectations. 5. Setup and teardown. Some unit tests might require a setup phase, where you prepare the environment for the test, and a teardown phase, where you clean up after the test. These ensure that tests can be repeated independently. 6. Mock objects. In some cases, you may need to simulate the behavior of components or services that your unit relies on. Mock objects are placeholders that mimic these dependencies, allowing you to test your unit in isolation. 7. Test coverage. Effective unit testing aims to cover as much of the code as possible. Test coverage is a metric that measures how much of your code is exercised by your unit tests. Higher test coverage means more confidence in your code's reliability. All these elements work together in a unit test, making sure that individual units or components of your code are thoroughly examined for correctness and functionality. Unit testing not only verifies that your code works as expected but also provides a solid foundation for maintaining and evolving your software with confidence. Why do we need to unit test? One of the most compelling reasons for unit testing is early bug detection. Let's explore how this can save you money. Imagine your software project is like constructing a building. Early bug detection is like catching architectural flaws during the blueprint phase rather than after the building is built. When you discover a bug or an issue in the early stages of development, it's far less expensive to fix. It's like fixing a design flaw on paper compared to tearing down and rebuilding a structure in the physical world. Research and industry data show that fixing a bug during the initial design and development phase can be up to 10 times cheaper than addressing the same issue in later stages of development or, worse, in a fully deployed system. The cost of bug fixing tends to increase exponentially as you progress through the software development lifecycle. Now, let's talk numbers. A bug that's caught and fixed during unit testing may cost, for instance, $100 to resolve. However, if the same bug goes unnoticed until the system testing phase or, even worse, makes it into production, the cost to fix it can skyrocket to $1,000 or more. That's a tenfold increase in costs. So, the exact savings can vary depending on the project's complexity and the specific bug. But it's safe to say that early bug detection through unit testing can potentially save you hundreds of thousands or even millions of dollars. In addition to cost savings, early bug detection also means less project delay, better software quality, and improved user satisfaction. What happens if we don't unit test? If you neglect unit testing, you're risking several critical aspects of your project. Higher costs, fixing bugs in later stages can be exponentially more expensive. Decreased reliability. Without unit tests, your software becomes less reliable, leading to unsatisfied users. Complex debugging. Troubleshooting becomes a nightmare when you're unsure which component failed. Difficulty in collaboration. Without unit test, it can be challenging for team members to collaborate effectively, leading to misunderstandings and inconsistencies in the codebase. Difficulty in continuous integration and deployment. Lack of unit tests can disrupt these processes, making it challenging to ensure that new changes do not introduce regressions. Investment in unit testing. Time, money, hardware, software, manpower that goes into it. Investing in unit testing isn't just an expenditure, it's a strategic decision that pays dividends. Let's break down the savings. First, consider time. Without unit testing, debugging and issue resolution can become a lengthy and unpredictable process. Studies have shown that unit testing can reduce the time spent on debugging by as much as 50%. Now, let's talk about the financial aspect. The cost of fixing a bug after it has made its way into the production phase can be up to 10 times higher than catching it during development. Unit testing significantly reduces the number of bugs that make it to the later stages of development. By investing in unit testing, you can potentially save thousands, if not millions of dollars, depending on the scale of your project. As for the required software and hardware, they are not just expenses, they are assets. A good set of testing tools and hardware components are investments that enhance your software quality. And let's not forget the manpower. While it's true that skilled manpower is essential for unit testing, consider the savings in terms of avoided overtime, reduced stress, and increased developer satisfaction. So, the answer to how much time and money can be saved with unit testing is quite simple. It can save you precious development time, potentially millions of dollars, and most importantly, it can save your team from the frustrations of firefighting and late-night debugging sessions. Let's explore best practices that can elevate your unit testing to a higher level of quality and effectiveness. 1. Automate your tests. Manual testing can be time-consuming and error-prone. Automating your tests ensures consistency and reliability. With automation, you can run your tests frequently, catching issues early and saving valuable development time. 2. Test boundary conditions. Don't just test the typical or happy path scenarios. Ensure that you test boundary conditions, which are the extreme values or edge cases of your inputs. These tests help uncover vulnerabilities and ensure robust code that handles all possibilities. 3. Integrate unit testing into your code review process. Code reviews are an excellent opportunity to ensure the quality of your tests. Include unit tests in your code review checklist. Reviewers can check if tests are meaningful, cover edge cases, and verify that they're correctly implemented. 4. Foster collaborative development. Unit testing is not just the responsibility of a single developer. Encourage a culture of collaboration where the entire team values and contributes to unit testing. This collective effort leads to more comprehensive testing and better code quality. 5. Document your tests. Good documentation is a crucial part of unit testing. Document the purpose and expected outcomes of your tests. Well-documented tests make it easier for other team members to understand and maintain the code. 6. Implement continuous integration. Continuous integration is a practice where code changes are automatically built, tested, and integrated into the project. Continuous integration pipelines can be configured to run unit tests automatically upon code changes. This ensures that new code doesn't introduce issues into the existing codebase. 7. Consider test-driven development, TDD. In test-driven development, you write tests before writing the actual code. This approach ensures that code is developed with testability in mind. It can lead to more robust and maintainable code. 8. Explore performance testing. While unit tests focus on functional correctness, it's also valuable to consider performance testing. Evaluate how your units perform under various conditions and work on optimizing critical components. 9. Maintain and update tests. As your software evolves, your tests should evolve too. Regularly update your unit tests to reflect changes in the codebase. Outdated tests can be misleading and lead to false positives or negatives. 10. Use test reporting. Implement a test reporting mechanism that provides clear and actionable feedback. A well-designed test report can help developers quickly identify and address issues. By incorporating these best practices, you not only ensure the effectiveness of your unit tests but also contribute to a higher level of code quality, maintainability, and collaboration within your development team. In conclusion, unit testing is the cornerstone of reliable and high-quality software. It's a practice that not only benefits your users but also your development team and your budget. Thank you for joining us on this journey into the world of unit testing. If you found this video informative, please like and subscribe for more insights. Remember, every line of code deserves to be tested and trusted.